In this video, we're going to do something very different to what we've done before. In our previous videos, we were using an electric current to make a magnetic field. Now we're going to do something the other way around. We're going to use a magnetic field to create our own electricity. In order to do this, I'm going to use a solenoid. This is a professionally made solenoid with 600 turns of wire wrapped around it. You can see the wire here, it's copper wire. It may look like this copper wire is not insulated, but in actual fact it is insulated. It is covered in a clear varnish. It's a solenoid because it's hollow. I'm going to hook an ammeter, a very sensitive ammeter, to my solenoid. You'll notice that the ammeter needle is sitting at 0 amps. The reason for this, if you think about it, is pretty obvious. There is no battery, there is no cell, there is no power supply in my simple circuit. All I have is my solenoid and my ammeter. So it's no surprise there's no current. However, I can make my own current using the process of electromagnetic induction. I'm going to try this now. If I take an ordinary permanent magnet like the type shown here and I move it near the solenoid, you will see that I actually am generating a very, very, very small current. The faster I move the magnet, the more current I produce. This process is known as electromagnetic induction, and it was first discovered by an Englishman called Michael Faraday in the 1800s. This process is how we generate all our electricity nowadays. Notice that if the magnet stops moving, we don't get any current whatsoever. I'm actually supplying the kinetic energy to make this process work. Unless the magnet moves, it won't work. Similarly, I can keep the magnet still and move the solenoid backwards and forwards. It doesn't matter which moves, so long as there is relative movement between the magnet and the solenoid. If there is relative movement, we will get a current. You will notice that we are producing an alternating current because the current is going in one direction past the 0 mark and then in the other direction past the 0 mark. So what I am creating is an alternating current. From the solenoid's point of view, the magnetic field is changing. When the magnet is close to the solenoid, the magnetic field is strong. When the magnet moves away from the solenoid, the magnetic field is weak. So when I move like this, from the solenoid's point of view, the magnetic field is changing. Only a changing magnetic field will produce a current. A steady magnetic field like this will not produce any current. You have to supply movement in order to generate a current. Michael Faraday went on to realize that there must be a more efficient way of doing this to provide this relative movement. He came up with a device called the generator. Generator consists of a permanent magnet and a solenoid that can rotate. If the solenoid spins close to the magnetic field of the permanent magnet, then a current will be created. This device is called a generator, and it is using the effect of electromagnetic induction. We can make the generator even smaller, like so. Here is a professionally made generator here. Inside this part here would be similar equipment to this. Inside would be a permanent magnet and a solenoid that can rotate. I can show you this if I rotate this wheel. By turning the generator, I'm creating a changing magnetic field, and the changing magnetic field is lighting the bulb. Note there's no battery in this equipment. I'm supplying the energy. Thank you for watching.